Okay, we have learned about the triple integral for Cartesian coordinate. So any question about that? I think there are something wrong here, right? For this question. Yes, there is a wrong here. So what is the correct limit here? You see here, okay, y is 6 minus x over 2. So when x 0, y is 3. When y 0, x is 6. Okay, correct? So your y is 6 minus x over 2, or your x is 2y, 6 minus 2y, correct? Okay, which is correct. Okay. X plus 3z equals 6, z equals 6 minus x over 3. Okay. Or your x is 3z, 6 minus 3z. Okay. 2y plus 3z equals 6, z equals 6 minus 2y over 3. Y 0, z is 2, z 0, y is z equals to 0, y is 3. Okay, correct? So z is 6 minus 2y over 3. Your y should be, this is not correct, 3, 6 minus 3z, right? Can you see? This is 6 minus 3z.
Over 2.
Over
2.
2. So,
You mean y, Doctor? Right.
huh? Okay,
Y
y.
equal.
Okay, yes. Thank you. Y equal. Okay. So, we're differentiating respect to simple yz. Okay, simple to yz. These are different now. So, for yz, if you see here, z is the same. Okay, z is the same. That is 6 minus x minus 2y over 3. Sorry, this is x. So x is equals to 6 minus 2y minus 3z is correct. And then your dy dz, which means dy dz cut at z. So here to here. Here is z0 to z, 6 minus 2y over 3. And your z is 0 to 2. Six minus 2y over 3. Okay, correct. So the first one is correct, right? Okay, see the second one. Dz dy, which means cut at y. Okay. Here to here. Y 0 to y, 6 minus 3z over 2. So this should be 6 minus, this is correct, 6 minus 3z over 2. Okay. Then I have 0 to 3. If you're differentiating respect to xz, it is here, right? Type 1 or type 2. So if dx dz, the first one is dx dz, cut at z. Cut at z. Okay. From here to here. Z is 0 to Z6 minus S over 3. Your Z is 0 to 2. Your X is 6 minus 3Z. X minus 3Z, 0 to 2. Okay. So this is your Y. Your Y should be six minus 3Z minus X over 2. Okay, correct. So how about dz dx? Dz dx, cut at X. So which means 0 to 6 minus X over 3. Okay. Yeah, 6 minus X over 3. And 0 to 6. Okay, done. So lastly, for xy plane, dx dy, dy dx, dy dx, 0 to 6, and the y is from 0 to 6 minus x over 2. Six minus x over 2. Okay, and dx dy will be dx dy should be 0 to your y should be 0 to 3. Your x is from 0 to 6 minus 2y. Okay. Okay, Ken, any question for this? Okay, and am I taught this for the polar coordinate? Am I taught you this before? Hello?
Not yet, doctor.
This is not yet.
Yeah.
Okay, so I will come back this later. Okay. So where we stop? Is it here? Am I taught the cylindrical coordinate to you? Saya ajar belum ini?
Belum.
Cylindrical belum
No.
So for plane, is it okay? Okay, for this question, if you see back, it's the same thing, same concept. Okay, it's the same concept. You asked to find the volume, just stick with the below one. And then you have to choose either simple xy, simple yz, or zy. Okay, you can study this. Okay, we come to cylindrical coordinate. Okay. So cylindrical coordinate is generalization of polar coordinate. We convert the triple integral from rectangular to cylindrical coordinate by writing x equals to r cos theta, r equals to y equals to r sin theta, z equals z. This just this. Okay, addition of this only. I cannot write here. Wait for a while. Let me open another one. Okay. Okay. So it is some sort same like polar coordinate, but now we have z. Okay. So your dv should be not this, r dz dr deta. So this is come from xy plane. We turn into dr deta. Remember, like your polar. So recall back the polar. Just recall back. If you see this, okay, if this is the region, your r is 0 to something here. So which mean must be in theta form, which is this is r squared equals to 2r cos theta, and your r is cos theta. So your r is from 0 to 2r cos theta, 2 cos theta. Okay, your r is from 0 to 2 cos theta. Your angle from here to here, which is 0 to pi over 2. Okay. Sorry, we have 2 here. Okay, at the bottom. Another one is here. So you have negative pi over 2 to pi over 2. But this is special. Okay. Your r is from 0 to 2 cos theta. Same as here. Same. Everything is same. Okay. Okay. This is special one. So that's why you cannot choose 0 to pi over 2. We have 2 shaded region. So we cannot write 0 to pi over 2. And then you have to write 0 to negative pi over 2. This is not correct. Okay. So negative pi over 2 to pi over 2, like this. Okay, whatever function is according to the question, but you have to change it to r and theta form. Okay, from xy to r theta form. Okay, for this is for sure 0 to pi over 2 because this is the region. Okay, so your angle is from 0 to pi over 2. Your radius from 0 to here, you have to find it from the equation itself. Okay, you will got same thing, 2, you will get 2 cos theta. So the angle is okay. If plus and minus, okay, this is a different thing. If plus 0 to pi over 2, 0 to 2 cos theta. If you have minus, and then we have 0 to 2 cos theta, the same radius, but your angle is negative pi over 2 to 0. Okay, always the lower limit should be the lower angle, and this is upper limit should be upper angle. Cannot put negative pi over 2 here, 0 here. Yeah, this is special. If only this. If both means it become the upper one, like this. Actually, you can do like this. So over 2 to 0 and plus 0 to pi over 2. But you will have two things, right? The same thing. So why not you just integrate in one single integral? Okay, one single limit. Okay. Okay, just recall back. This is 0 to pi over 2, pi over 2 to pi over 3 pi over 2, 3 pi over 2 to 2 pi. This is negative pi over 2 to pi over 2. This is pi over 2 to 3 pi over 2. This is pi to 2 pi and 0 to pi. Okay. So for this, you have two things. One, this is shaded region that we want. So your angle should be one is here, which is exactly pi over 4. And another one is here. Okay. Which is pi over 3. How I get pi over 3 is come from this equation. I get pi over 3. So this is 45 degrees. And this is, I think, 60 degrees. So it should be lower to upper angle. If the radius always the same, 0 to here, which is from here is 4 squared. So 0 to 4. Okay. So remember this, if I ask you to do a poster, make sure you include this. Okay. And some tips here. Yeah. Some tips. Okay, any question? Before we move to cylindrical coordinate.
Doctor,
Yes.
what if the circle is like different portion?
I can't imagine. Can you draw or something?
Okay,
Try
okay,
to
wait.
give in the telegram.
Not yet, Doctor, not yet.
Okay, okay. Okay, let me see the telegram. So which one? Okay, how to do this? Okay, if this you have to split into two. So if this is the case, so if I see here, one is from here to here, and another one is this here to here. So you have to do, if it is involving double integral, you have to do two double integral. Say that, okay, for this case, so again, one is here, another is here, right? Correct?
Yes, Doctor.
It's in different color. Okay, this is, we have two regions. So the first region, as usual, 0 to pi over 2. Let's say you have double integral 0 to pi over 2, and whatever radius is it, plus r d theta, plus, and then from here to here, which is pi to pi. Okay, you can include this in your poster. Okay, please include it. Okay.
So, jadi, so there's like no way to make it like one.
Cannot, because it is moving. Either move here or move here. If you want to merge it, maybe you can merge these two, but we have left here. For this is negative pi over 2 to pi over 2. Okay. But here how? We just left here. We cannot merge it because we have, they must interconnected. If you see here, everything is connected because we are dealing with the area. Understand? You cannot merge it
Okay.
into one. If you see this example, you cannot merge it into one. Okay. So either like this, or you can merge these two and plus with this one. or first this or second this. Same if I put here only or here only. So one is from here to here, another is here to here, anti-clockwise. If I put like this, and then these two and this. If like this, easy, just directly to here. Okay, pi over 2 until this is 2 pi, is it? See, yes, 2 pi. Okay, no need to split. Okay, can.
Okay, can Doctor.
Okay. So let me move to cylindrical coordinate. So it is extension from the polar coordinate. Just we add z equals z, and your dv again is rdz. Is it rdz dr data? So not this. So please amend. Okay. Then okay. So same. This is your positive x. This is your negative x. So this is negative y, and this is negative z. So your theta should start from positive x-axis, which is polar axis. Just positive here, negative is here. Okay, because for r theta it is 2D. If you look from the above. Okay, and then your r should come out. Come out from the origin. Same like before. R and theta is come from xy plane. And this is the tips for the coordinate. Your z is the height, either positive or negative height. Okay. So this is the derivation. You don't need to know. Okay. So this is the correct one. R dz dr d theta. No interchangeable. No type 1 or type 2. For your syllabus, we just move like this straight away. So for Cartesian, maybe you have a lot of type, 6 type, right? 3 type, but you can split into 2. So 3 times 2 will be 6 different ways. But for cylindrical or spherical, after this, you just follow the element of the integration. Same. Actually, this is dv. Your dv will become r dz dr d theta. So this f is r theta z. Your z must be function of r theta or constant or r only or theta only. But for a while, okay. So this is your dv. Your f must be function of r theta z. Cannot be any xy. Your region this for this dz should be function of r theta. Okay, if I write like this, okay, let me see. So this is your z, right? Z1 function of r theta. This is limit for z2, it is higher than z1, the theta. For this is r, your r must be function of theta or constant. And lastly, your angle should be in radian. Okay, constant is a constant, purely constant. Okay. Okay. Use cylindrical coordinate. So this is one of the famous question. Sketch before chapter 1, chapter 2. So to change this into r dz, r d theta. So everything should be no x, no y, and this should be angle. So first you have to sketch this region, and then you have to see how the limit is described. Okay. Okay. So first we sketch. So to sketch this, what is this actually? Z is equals to 9 minus x squared minus y squared. Right? So this is parabola when say z0, this is x squared plus y squared equals to 9, circle radius 3. Okay. If x is 0 and this is 9 minus y squared, which is parabola. Okay. When x is 0, you have 9 here, and y is 0. When z is 0, y is negative 3 to 3. So you can imagine the 3D will be like some sort like, okay, some sort like, okay, 3, right? This should be smaller. Okay, this is the circle one, and then it is, okay. So the lower part, and this is the upper part. Okay. So from here, you can see from this bottom, your radius is from 0 to 3. Your angle is from the bottom also. The data dr is from 0 to 2 pi. So how about your z? Your z is from 0 to 9 minus r squared. Done. If you see the answer. So remember, study back your chapter 1. Make sure you master to sketch 2D and 3D. So if you see here, your limit and theta, you just see the bottom one. Easy. Okay. For z, you have to see here. Z is 0 until the surface above. Okay. If I split this, okay, if I split this, okay, this is this and this. So this is the lower limit. Lower limit. This is the upper limit. The lower limit is z0, and the upper limit should be z equals to 9 minus r squared. How? How I get it? Z is equals to 9 minus x squared plus y squared. Remember, for polar, x squared plus y squared is what?
R squared.
Yes, r squared. So the most important thing is the limit. Then you have to substitute in the triple integral. Your z is from 0 to 9 minus r squared. Your r now is 0 to 3, and your theta is from 0 to 2 pi. Okay, and then you solve. Okay, how I get this? This is just from the question itself. Yes, because of this. The question asks you to find triple integral x squared. So I just substitute x squared. What is x squared? R cos theta. R squared cos squared theta. Okay? Can? Okay. Can. Why we use this cylindrical coordinate? Because the surface we have one of the surface is the circle. More to cylinder. Okay. Cylinder is just a circle if you extrude it in 3D. Okay. So others is just a calculation. Do the inside one first, and then the outside and the outermost. Okay. Evaluate the integral by changing coordinates to cylindrical. Actually, you can do in Cartesian form, but if you see here, we have parabola, cylinder. So you can use the cylindrical coordinate, which is more easier. So if you see the other question, first you have to draw. You have z equals to this, which is sphere, which is hemisphere, because only positive one, because here we have only positive. And then you have a circle with radius 1, hemisphere radius 4. Okay. So if you see this, we just consider the positive one, which means 0 to 1, 0 to positive, 0 to positive, only in first octant. So somehow, if you see here, we have one hemisphere. Okay. If you see, I assume that you can draw this. One is this, and then we have a circle part here. Okay, and then we have, actually this is like this. Okay, because everything is in sphere. So we just cut this. Okay, in the first octant, we put this like this. Okay. So from here, your angle is 0 to pi over 2, your radius is 0 to 1. We didn't take for 4. Sorry, this 2. This is 2 squared. So we don't want to take 2 because 1 is bounded inside 2. Okay, and your z is just 4 minus r squared square root. Okay. So they didn't say anything about the, let me see. Well, other next question will be, oh, this only one, z. Okay, they put z, so you just put z here. So because they are nothing to do with z, because we want in z r theta or r theta z. Okay. Next one. So this is your z is 0 to x. Your x is 0 to square root of y squared, and y is a -1. Okay, this is different. So when you draw this, okay, so this is y. Okay, 191. And then you have x. This is a circle, right? This is circle with radius 1, but we only focus in the positive side. Okay. Okay, but we focus on positive side. Later we see how. And then what we have else? Nothing. So -1 to 1, which means it's just here only. We don't want the bottom part. Okay. Or it's nothing, it's just a circle only. Okay. Okay. So if you want to draw 3D, or we have a line, right? See the line we have. So first we know this. We already know this.
Doctor,
Yes.
I don't understand how did you get the circle?
Okay, how I get the circle. Okay. See here, your z is from 0 to x, correct? Correct.
Yes.
So this is a plane. They will cut the circle later. Your x is from 0 to square root 1 minus y squared. So x is 0, x is square root 1 minus y squared. If I square both sides, I will get x squared plus y squared equals to 1. So that's why I get circle. But I have to focus only on positive square root 1 minus y squared. Understand?
Okay, I understand, doctor.
And then you have y equals to -1 to 1. So you have to merge all this, right? Y is -1, x0, and then you have circle, but only the positive one. If I draw the traces, yx. So if x equals to, let's say I put x0, y0, x is 1, and then when x is 0, x equals to 0, you will get y is positive 181. So it's like this. That's why this is a traces. Okay. So and then I have to merge with z equals to x. So if z equals to x means it's nothing, right? It's just when x is 0, y is 0. Z x 0, z 0. X is 1, y is 1. So it's just a straight line. But we want 0 above, so we don't want here. We want the one here. Okay? We don't want when x negative or z negative. So it is straight line. So this and this we have. So it is difficult to draw actually. It's easier to use the Cartesian plane, but it's okay. They ask you to change in polar. So you have like this. Okay, when z equals to z equals to x, they cut. And this is y negative 1 to 1. If I change the direction, maybe you can see directly. Yes, like this. If I change this x to here, you can play around with the x, y, z if you can see properly. So it is just moved backward. Okay, it does slice. They cut because we have z equals to x. You have to see, try to see again and again, try to imagine. So this might be hard. Okay. So from here, okay, from here, actually from the question also you can directly do that x is r cos theta. Then this you can have to change to r and theta. So this is 0 to x, which means r cos theta. Or you can see here, this is z0 and this is r cos theta. Okay. Then your r is 0 to 1 because your circle is 0 to 1. And then your angle is negative pi over 2 to pi over 2 because this is in y plane. If you see here, this is negative pi over 2 to pi over 2. Okay, negative pi over 2 to pi over 2. It's not here. So that's why you have to be very careful for the angle. Then everything you can solve for your own. Can.
Canada.
Okay, so next question. Okay, we see what is the question. Okay, this like this. Oh, application. Okay, remember application for CD coordinate? It's just the same as before. Volume will be double integral, triple integral, 1 dB. So we don't have surface area here. So surface area will be 1 dB, 1 dA, sorry. This is for area. Volume we have two, double integral, ZdA. Okay. So if the element you found easier to solve in cylindrical, you have to change to R dz dr dθ. Fixed. Okay. Okay, this is just the same thing, but I will. Okay. So if you see here, Z9. Okay, if you see directly, Z9, what is Z9? It is just a plane. X squared plus Y squared. Okay. If
Circle.
Z equals to 9, I have to substitute here first. Okay, I have to substitute first. So I have x squared plus y squared equals to 9. So not a plane. Okay. Okay. And then I have a circle with radius 3. Okay. Then I have z equals to x squared plus y squared alone. So which means if I find the traces, I will have a parabola. If z0, circle, okay. Z9 is a circle, okay. But when x is 0, you will get y squared. So this is parabola. Also, when y equals 0, I have this. So I will have a parabola and a circle inside. So remember, for your, you have to change in z, d, r, dz, d theta. For z, it is from 0 to here, right? When z0 and z until 9. Okay, remember z is the height, but for your r, you have to see the xy plane, which is 0 to what? 3, because that is 9. Okay, and then your theta 0 to, from here, anti-clockwise. Where is it? Here. Okay, remember your angle start from 0 to 2 pi, because this is your region, everything, and it is moved anti-clockwise. So that's why your z is r squared to 9. Okay, see why r squared? Oh, okay, if you see here, this is r and this is 9. So it is r squared to 9. Okay, I forgot about this. So we have 2z, right? It is clearly, it is from r squared to 9. So your z is r squared to 9. Your r is 0 to 3 and 0 to 2 pi because of this circle. Okay. Also, if you cut here, also you get a circle. But it is must follow the xy plane. So xy plane turns into r dr d theta, same as dA. Okay. For the z, it is r squared to 9 because it is given in the question. Okay, then others is just follow. This is one. So first you have to integrate respect to z, you get z from r squared to 9. So you get this, and then differentiate this with respect to r, you will get r squared over 2, r4 over 4, and then 0 to 3. And then that answer you have to integrate with respect to theta, you will get theta, then you just minus. Okay, write in 4 decimal places or leave it like this. Okay. Can?
Doctor,
Yes.
can you repeat what is it r squared again?
Okay,
I thought
because
it was
from the
0.
question, yeah, I also thought 0, but the thing is from the question you have here, from the question, they give you z equals to x plus y squared, xz equals to 9. The height is x squared plus y squared, which we don't know the radius until the z equals to 9. Because here at this solution, this when your x squared plus y squared, we don't know the radius. That's why we put x squared plus y squared. It is in the question. That's why we have to move to r squared. We cannot put 0 because we don't know the r. I cannot put simply this 0.
Okay, understand, doctor.
This circle can be here. Can be here. But the maximum is 9. This is clear. Okay.
Okay, doctor.
Okay. So next Okay, we see other question will be 1B. Okay, let's see this. Okay, this is, I think, it's a circle. Okay, this is clearly Z0. And then we have Z equals to X squared. Again, is paraboloid. Okay, so the circle is shaped here. Circle will lead to parabola, sorry, cylinder. And this is parabola Z0. This is clearly Z0. So, so the bounded part is here. Yeah, this is the bounded part, okay, which is this. If I cut, this is Z0 to Z equals to X squared plus Y squared, okay, which is R squared. And then your radius now it is moved to right hand side, so 0 to 2 cos theta or 2 sin theta. Here will be 2 sin theta, okay, because it is in Y. So that's why it is 2 sin theta, as you have learned in engineering maths 1. For circle that is inside the y-axis will be sine, and if circle is here, will be the radius will be cos. Okay, and then your theta is what? If you see this, the theta is from here to here, which is 0 to pi. Okay, can this parabola, we don't have any radius, so the parabola should be no n. But luckily we have this, which means the parabola can follow the radius of the circle or cylinder. That's why we cut this. Okay. Okay, can? Then others just follow 0 to r squared. Remember, no x and y after you convert it to cylindrical unit. So remember, do inside one first, and then the second one, and then the outermost. Remember, if you find something like this, you cannot solve. You have to change the identity because this is simpler to integrate. Other than this, you cannot integrate sine square directly. Remember, so this you have to refer back what you have learned in engineering mathematics 1. Okay. Remember this, the cos sine 0 will be 0. Okay. Okay, 1C. You have this again, parabola, a circle, Z0. Clear? Z0. So the intersection part will be the bottom part. Okay. So Z0 to Z equals to X plus Y squared will be 0 to R squared. So your radius is 0 to 2, 0 to 2 pi. This is easy. Okay. Sometimes you can easily see the limit, but you have to draw first. See the intersection. Okay. Okay. Is it okay?
Okay, Doctor.
So we rest for a while, 5 minutes, and then we continue about the spherical coordinate. Okay, Assalamualaikum. We continue to spherical coordinate. Okay, spherical coordinate is a little bit different with the cylindrical coordinate. We see here. Okay, for spherical coordinate, for let's say for this, okay, for this, if I have a cone and have a sphere, and then how to say? Okay, the Z is the phi. We consider phi for Z. Okay, Z we will consider as phi. We will substitute the angle of Z as phi. It's different. So now we will consider the angle from the vertical. Okay, and then we have Z equals to rho cos phi. Okay, so you have angle of phi, and then you have theta also, like usual. That is x equals to r cos theta, but your r is rho cos phi. Your rho is the radius to the sphere. Your rho focus on the sphere. Okay, and then your r is focus for theta, but we already substitute with phi. Then next thing that you have to know is your x squared plus y squared plus z squared will be p squared, which is radius of sphere. Rho is radius of sphere. For cone, cylinder, we use r, radius. You remember, for sphere, we use rho, which is the radius must touch the sphere. Okay. Sphere, hemisphere, ice cream cone. Okay, let's say I have ice cream cone, and then I want to find the limit. Here should be the dV. Okay, next thing about the dV. Where is the dV? Okay, this dV will change to rho squared sine squared phi d rho d phi d theta. Okay, I think this is a little bit different. Let me go to the notes so that you can understand. Okay, so we have hemisphere and cone, so it is easier to use the spherical coordinate. Okay, so useful when you have spherical or ice cream cone surfaces. So spherical coordinates represent as p in a space, which is a rho, radius of the sphere. P, it is angle in the z-axis, and theta, which is referred to r. Okay, refers to the circle, that xy plane. So rho is the distance from P to origin. Okay. Phi is the angle that makes positive axis 0 to pi. So 0 to pi is the maximum. You cannot go beyond that. Okay, phi should be from 0 to pi, theta from the cylindrical coordinate. So this is easy. I will show this and this. Okay. So if you see here, your angle should be clockwise. Okay. Same as cylindrical. Your radius here, your phi should be from the origin to the sphere. Okay, and then your z is rho cos phi. Okay, from the simultaneous equation. Okay, your z is rho cos phi. Okay, so your x is rho sine phi cos theta. Your y is rho sine phi sin theta. So don't get mistake. Your r is rho sine phi. Your z is rho cos phi. And then x squared plus y squared plus z squared will be rho squared. If you substitute this too, you will get this. You don't need to know the derivation. So you just have to know that the substitution part, the x, y, z, and this. Okay. So your dv will be rho squared sine phi d phi d rho d phi d theta. It is long. For cylindrical is easy. Z dz r dz dr d theta. So for spherical should be like this. So for triple integration, if you have something like this, and then you have to change the dv to this everything, copy, and no interchanging. They must be reoccurrence. We cannot put d phi d rho, d phi d rho or d theta first. Just follow. As usual, the phi must be function of theta or phi or both. The theta must be function of the phi must be function of theta, and theta is constant. So d rho must be function of phi or theta or both, or phi only or theta only. Your d phi should be function of theta only, not d rho, and d theta will be constant like usual. Okay. So we see some questions so that you can understand. Use spherical coordinate to evaluate this. So this is what? Let's say I put like this. So this is just rho cube. Okay. As we learn here. Yes. Rho squared, sorry. So rho squared cube. So you might be confused, but if you know the concept, and it will be easy. Okay. So this is actually is rho squared cube will be rho of 6. And then bounded by this and this. So you have to sketch. Okay. So everything is just a question. Okay. You see the answer. Is it? Cos. Which one is? Okay, solution is here. Okay. So if you see here, you have to sketch this first so that you can see what is going on. So this is sphere, right? With radius hemisphere, which is we have radius 1. Okay, we have radius 1. So positive means from the question we have only positive, so it's just a hemisphere. So from here, okay, you just focus on the above part first. So your angle is okay, 0 to pi, 2 pi. Your phi, remember your phi start from Z and it is clockwise. Okay, let me see. Is this correct or not? Your Z, yes. You see the movement of the phi should start from polar Z axis. I mean Z positive, and it is clockwise. Theta is anti-clockwise, and stop at the region given. So here we stop. We start from here. We stop here, which is 0 to pi over 2. And your radius until here is 1. Can you see it? You have extra thing now, other than you just see the angle from here to here. You have to see the angle of the P, which is start from positive Z. And the maximum should be until pi. Why? Because if you rotate until here, you will get the same back. Either here or here, the angle should be 0 to pi. Your phi should be 0 to pi maximum. Your theta can be rotate 0 to 2 pi. Your radius can be anything. It's according to how big the radius is, the sphere is it. So you already have these three angles. Now should be easy. You can put 0 to 1 for your phi. For your rho, this is rho, this is phi. Your phi is 0 to pi over 2 and theta is 0 to 2 pi. And this everything is just rho squared. Rho squared. And then we have cube and then we have square root. So you will have rho cube like this. Inside cos. So you have cos. And then everything this is dV. So understand this first. Others is just a calculation. This is first one, you have to integrate respect to this. Then that answer integrate respect to phi. And that answer should be integrate respect to theta. Understand? Understand or not?
Understand, Doctor?
Doctor, why
Yes.
the pi cannot be 0 to 2 pi?
Okay. About the phi, right? This phi.
Yeah, the phi. Yeah.
Okay. The phi is the maximum. Okay. The maximum of phi is just to 0 to pi. Okay. Why cannot until 2 pi? Good question. You see here, the positive angle, the phi is the angle that makes positive z-axis. Okay. If I rotate from here to here, it is same as if I rotate here to here. It is you cannot measure from here to here. It is not applicable. Understand or not? This is the maximum. They only apply to 0 to pi over 2. Or from here to here. Because this side and this side are the identical for sphere. Okay. Later I will find more reason why this cannot. But for your syllabus, you just have to know that 0 to pi. Okay. Later I will find why it is maximum pi. There are some reason there.
Okay,
It is
thank you,
moving,
Doctor.
it's already moving like this for circle. And then for the vertical one, they can't move like that. Okay, wait for a while, I will come back.
And
Yes,
Doctor.
Doctor.
Okay, so we continue for a while. Okay. Okay, so you see the B1. So we have a lot of example here to A to B to C. Okay, then we will see something. Application we will move to tomorrow class. Try to finish this. Okay. Okay, you can, if you find it is very long, you can do one by one first. This part, you just extract it. That answer, then you can do the P part. And then that answer put in the theta part. Okay. So question 1B. Okay, this is actually is rho squared. Done. We have rho squared here. The square root of rho squared will be rho cube. So you have this too. So this is somehow is like parabola, is it? Okay. This is sphere. Oh, this is not parabola. This is like cone, I think, because when you square both sides, square. So it is a cone. So cone and hemisphere will become ice cream. Okay. So if we draw this, we will get a cone and then positive cone. So no need to draw the bottom one. and the hemisphere because it is positive square root. And then if I cut this, this is the okay, and okay, and also this part. Okay, so what we can see is your theta is 0 to 2 pi. Okay, and then your phi is from positive z clockwise until the cone 0 to pi over 4 is exactly 45 degrees. You can also find this from the graph. You can do by yourself because the z is 1. Okay, and then what else we have? Okay, your rho is 0 to 1. Your rho is 0 to 1, which is radius of the hemisphere. 0 to the sphere, not the cone. Okay, 0 to the sphere. Remember. Okay, your dv will be rho squared sine phi d rho d phi d theta. Okay. Okay, then you can do this by your own. The thing is, the limit must be correct. Okay, very long. You have to see. Okay, 1 and then 2a. This is the question. Okay, we see the question first. Okay, 2a, we have this. Okay. So again, this is just a line. So it is referred to plane. This will be the circle, right? Circle with radius 2. We have both sides, negative and positive. You have to consider both. So it is a complete circle. And one is here, which is cone, I think. Cone, positive cone. And then the right hand side is the hemisphere. So again, it is a ice cream cone. Okay. Okay. So from here, you have to know the phi, radius of phi. Okay. The angle is 0 to 2 pi. Your phi is again the same, 0 to pi over 4. Now you have to know the phi, right? So phi is here, which is in the sphere. Remember, phi refer to the sphere. So if they give like this, you can square both sides. And then this 8 must be square root. Square root 8 is just 2 square root 2. Okay? Is 4 times 2, which is 2 square root 2. Okay? So that's why your radius of the sphere should be 0 to 2 square root 2. Okay? Okay. So C to C. Okay, this is your limit. So this is again a sphere with radius 2. And then this is a cylinder, positive cylinder, but it is only positive x. And this is plane, y equals to x. Okay? And then you have the y is equals to 0 and square root 2, fixed constant. Okay, so if you draw that, you have a sphere, positive x-axis, semi-cylinder. Okay, because we only consider in positive when x equals something, which means it is in the this side. Okay, so when you take out this to see the limit, where is it? Okay, you will get this. Okay, so your radius of the sphere is from the sphere itself, which is 0 to 2. Okay. And then it is in the first quadrant. The angle should be 0 to pi over 2. Okay. And then your theta, where's your theta? Your theta is from 0 to pi over 4. Okay, because it is from here to here. It is anti-clockwise. For phi, it is here to here. 0 to pi over 2. So don't confuse. Okay. So after you get the limit, you can solve anything. Okay, 2c. You have y is from negative to 2, which is fixed. And from here, you can get a circle, which is lead to cylinder. And then this is a sphere, hemisphere, full sphere, is it? Yeah, because negative to positive. So you have to draw a full sphere here. And then what we have cylindrical here inside. So for sphere, the radius is 2. For cylinder, radius also equals to 2. And the angle is 0 to 2 pi. It is cover inside because we have radius 2 and your cylinder also 2. So your cylinder is inside actually. It is inside. So you have 0 to 2 for sphere, phi 0 to pi. See, we cannot exceed more than pi, as written here. Okay, we cannot put until here. Okay. So others is just calculations. Okay. So for application, we have same thing, triple integral 1 dv as a volume, also for Cartesian, but the dv is rho squared sine phi d rho d phi d theta. Okay. So if you see some application here, so this is a sphere which is moved on 011, 001, and then this is another sphere which is radius 1. So we have like this. Okay, so this is the shaded region. Okay. Okay. So if you have question like this, please factorize first, operating the square, and then you can come to solving the triple integral. Okay. So others we can continue later. This application later. It's just same as double integral, but I will show you tomorrow classes. I think tomorrow is it our class?
Yes, tomorrow, Doctor.
So okay, any question for spherical? So I will stop here and try to revise. Okay, see some YouTube or internet to study about the spherical and the cylindrical. Okay. So assalamualaikum and good evening.
Waalaikumsalam.